very next moment as the A starts moving, will B and C will move? No. The string will become loose, no, here. So I'll give you supporting diagram. You see this. This will be the state of string. And finally, when string makes an angle, theta equal to 30 degrees, then what happens? The string will be jerked here. No? So this is what happens here. Now very next moment, the string will be jerked. Will I agree this? So I just picked up this problem so that immediately when you project, it will not be jerked here. It all depends upon the condition. It will continue to move with a speed u. I'm showing in one diagram everything. So now what will happen? Very next moment after this, it will be jerked. When it is jerked, what conditions will arise? We'll see. No, what can happen to the balls? How do they move? There's a ball C, ball B, and there's a ball A. So what is the best practice? Resolve the velocity of A along the string and perpendicular to string. So this should be the U parallel, U perpendicular. So what will happen to that U perpendicular? Should remain same. So after impulse, so what are the velocities? This will be VA parallel. String will be jerked. Shall I show it here only? It will be jerked J1, and this is J2, and this is J2. Because of that impulse and initial velocity for particle A. What are the velocities? So VA parallel, and this will be VA perpendicular. How the for B you have to show that VB parallel, I think, yeah, VBX, VBY. This will have only VCX. Sir, why C will move only along X? Look at the impulse acting on the C towards right. So VCX. For B, for A, U parallel will change because of J1. So I'm writing VA parallel. What about VA perpendicular? Will not change. I'm very sure it will become U perpendicular because this component is perpendicular to string 1. So this will be as it is. What about B? Why we have to show? So somewhere it will move. So therefore what happened? Because of impulse J1 cos theta and J2, it will have X component of velocity. Because of J1 sin theta, Y component of velocity. So I'll put it in this way. Okay, let's get into the writing impulse momentum equation. Then VA perpendicular must be equal to U perpendicular. So this is theta, this is theta, this is theta. So what is U perpendicular? U perpendicular should be U sin theta. U parallel should be U cos theta. U perpendicular should be U sin theta. And VA perpendicular, and this should be equal to VA perpendicular. Okay, write impulse momentum equation on the particle A. For A, it will be M. Particles masses are different. M1, M2. I'll write it. MA, I'll write it. Let me retain that symbol. MA U parallel minus J1 is equal to MA VA parallel. There's a one equation. Then for the particle C, J2 should be equal to MC VCX. For the particle B, J1 cos theta minus J2 should be equal to MB VBX, and J2 sin theta should be equal to MB VBY. I think we have plenty of unknowns. Look at plenty of unknowns. J1, J2, VA perpendicular only we know it. VA parallel, J1, J2, VA parallel, VCX, VBX, VBY. We need few more set of equations.
Sir,
Uh,
sir, in the fourth equation, shouldn't that be J1 sine theta?
what I wrote now? J1, okay,
J2,
fine.
sir.
J2,
Fourth equation.
symbol. J1 sine theta equal to MB VBY. Okay, fine, yeah. Now, what to do next after this? Unknowns are more, no? I'll take constant equation. Velocity of the ends along the string must be equal. So therefore, VBX equal to VCX. Component of VBY along the second string should be 0. So therefore, this I'll call string 2. This is string 1. For string 1, or the first string 2, we'll write it. VBX equal to VCX. Any reason? Because string is inextensible, no? And now after this, come for string 1. For string 1, VA parallel must be equal to VBX cos theta VA parallel should be equal to VBX cos theta plus VBY sin theta. This is the equation 5. This is the equation. Solve it, you'll get the required answer. So now, whenever one string is there, either two strings are there. String is inextensible. So velocity of the ends along the string must be equal because the string is inextensible. Why equation 5 and 6? What is the basic idea for 5 and 6? As string is inextensible. String is inextensible, then velocity of the ends along the string must be equal. Velocity of ends okay, no? So this is about the more than one string will come. Sir, why impulse? Why not be same in both the strings? They're two different strings, no? You go back to the basics here. You pull this by a force F. What do you expect the tension in both the strings? Will be different or same? Will be different. I'm asking you to go back to the basics here. So many of you have come across this. M1, M2, M3. If I apply force, will you put same tension in both the strings? No, different tension, no? We write like this, no? No, instead of this force, I'll apply impulse. Tell me what do you expect the impulse here? J1, J2, fine. Simple idea. Now instead of straight, you make it. See, you have to build up the ideas here. It's not that something, okay, I'll solve this problem, I'll apply. Why only I'm thinking like this is very important. When I apply impulse, so definitely here also the impulses must be different. See, if you apply force, when you apply force, so what do you expect the tension here? Here it will be T1, T2 at that instant. Then this T1 is only now will become J1. Why C will go in Y direction at that instant only we are discussing. No, it will move just horizontally. Look at the question, read question, the velocity of the particles just after string is jerked. We are not discussing after some time, just after. So there's a core idea. Why only I'm thinking, why only, sir, why only, why J1, J2, you're too different. I think you should not accept blindly. You must come back to the concept because as I go for next higher level problems, no, the background, this is needed. Okay, I'll take the next one.